Our presentation is covering which methods work best for monitoring sea turtle nest predation. So, what is the problem? Sea turtles globally face significant conservation challenges. In just Florida, there are 5 species that are all at risk, including the critically endangered hawksbill and Kemp's Ridley. Hatchling survival is threatened by natural predators like birds, crabs, fish, and raccoons. Researchers aim to understand this nest predation dynamics on the Florida's East Coast, and in doing so, need to choose the best method to document this predation. And this remains a challenge today. In this presentation, we're going to evaluate camera traps, track traps, and the USA/drones for recording effectiveness. The first method is camera traps. A camera trap is a remote device with motion or infrared sensors that capture wildlife photos or videos in their natural habitat. This is used in research and conservation and monitors their behavior, ecology, and populations. Some of the pros of these camera traps are in identifying nest predators, particularly within conjunction with other different techniques. There's mechanical triggers that can be placed within the nest chamber, specifically of sea turtle nests, and there's already studies that do so that prove that it's effective. There are notable successes in detecting a diverse array of these predation species. It is very cost effective, has continuous monitoring that requires less in-field participation for the researchers. It minimizes disturbance of the nest, so it's very non-invasive, and it offers the opportunity to study animal behavior, such as the hunting patterns of the predator species. Some of the cons include that researchers often have to opt for the less expensive recreational cameras over the pricier professional ones. There's deployment issues such as aligning time and the laborious and inaccurate process of the setup. There's operational issues such as retrieving the data or replacing the batteries. And there's data management issues such as processing a large amount of data, which takes too much time. There are also obstacles surrounding the trigger system, and the effectiveness of the camera traps can vary.
The second method is track trapping, which uses a lined area with traps that have natural or artificial substrates, and they're strategically placed in areas where there is lots of animal movement and can be baited or unbaited. For the pros, the beach is a natural substrate. It's useful for tracking small to medium-sized predators, and it can produce a predator activity index to help determine the number of predators at nesting sites. There's also a high detection frequency, and it's very cost-effective and an efficient method for measuring small-scale predation risk. However, the cons do include that it can be restricted to specific pathways animals take or prefer. Some species do not follow these specific pathways, which can make it trapping their tracks ineffective. There's also environmental factors that remove tracks. It's labor intensive and requires consistent data collection in the field. It can be impacted by humans and domestic animals, and the identification of the tracks are also highly dependent upon the ability of the researcher.
The third method is USA or drones, also known as unmanned aircraft systems. And they're a recent addition to wildlife research and are operated mainly or remotely to collect visual, quantitative, or geographical data. Some of the pros are that they enhance surveillance and contribute to the safety of the rangers or researchers. They conduct population counts that are very effective, and sea turtle initiatives are leveraging drone technology, predominantly employing the red, green, blue cameras for daytime monitoring research and conservation endeavors. It's very non-intrusive, it has real-time data, and the aerial surveillance is large areas of application has very clear view.
For the cons, though, they can be very expensive. You have to get permits and you have to follow certain regulations. It's time intensive and requires manual drive. Program difficulty distinguishing between different species. And then there's also the drone silhouette, sound, and flight behavior can cause disturbance in some animals. So our recommendations would be to use a combination method of the mechanical trap and tracking plot. So this can ensure a comprehensive research by offering a backup option if one fails to capture a predator. Reduces field time for researchers and decreases the amount of data to analyze. However, if there is funding available, the UAS drone would be just as effective. It can track predator movement, offers efficiency comparable to the recommendation we provided above, and it reduces overall field time. And that concludes our presentation. Thank you.